What we have done is we have shown the world a little bit, just a tiny bit, of what is possible. And we picked a particular application of robotics that I think is very, very close to everyone's heart, which is making the world safer from disasters. We will remember this day as the beginning of that work, and I cannot wait to see what all of you will do in the future.
The Department of Defense has an implied mission of responding to disaster situations around the world. What we're seeking to accomplish is pulling robotics to assist humans in responding to those situations. But when you do that, you have to make sure the robotic systems are trustworthy. They're going to accomplish the goals that you need. They will not be more of an impediment than a help. And so the result is that you need to develop the technology, mature it, experiment with it, and develop a sense of trust and confidence that the technology you developed is going to work in support of the humans.
It all started at a meeting at DARPA, where we introduced the idea of the robotics challenge to some of the country's best robotics institutions. We initially funded around a dozen of them to both develop hardware and to write software for one of our robots. What robotics really can do is to give us more resilience, to try to stop the disaster from getting out of hand. Can we have a robot go in where it's too difficult or too dangerous for a person to go? Can we better control what were once out of control situations? In 2013, we had a virtual robotics challenge, which in simulation allowed any team that wanted to compete against the ones that we had chosen through proposals. These teams, all of them, quickly proved that there was great potential here. The unveiling of the Atlas in 2013 to the 6 teams who had won the virtual robotics challenge was an extraordinary event. It was over 6 feet tall, weighed 350 pounds. Best of all, it could balance on 2 legs and walk around on really rough terrain. It had fairly powerful arms and a whole amazing set of hands that could pick up different objects and manipulate tools. These are the highest performance robots that we could find for these teams to use. Later in 2013, we met in Atlanta. There were 2 purposes for that meeting. The first was for the teams to all see each other, for them to know exactly how well each of the teams was doing. The second reason was for us to see how the teams were doing so that we could adjust the difficulty of the challenge, to not be too easy, not be too hard, but to be just right.
We welcome you, everybody, to the DARPA Robotics Challenge, the trials of 2013.
I think that the DRC trials were very much like what happened to Kitty Hawk, where the Wright brothers first flew and it only lifted off for a few seconds, but they knew that they were onto something. At the end of the DRC trials, we knew we were onto something. Most importantly, the rest of the world did too. And here we have prototype robots that are going to show us what the state of the art is right now for robotics for disaster response. We know that robots are slow. We know that they are somewhat unsteady on their feet. We think that they're about at the same stage of competence as a 1-year-old child in terms of their locomotion competence. What we really want to do is establish a reference point so that a year from now we can see how far we can get. Many of the teams did very well during the trials, and most importantly, they showed us that the robotic hardware that they had used was in fact very, very good. And so from now on, the teams could focus on software and on autonomy and dealing with the most difficult of the problems that you have in disasters, which is communications. Once the trials were done, we visited Fukushima and we took 7 of the participating teams with us. It was really important that they see firsthand what the problem was that we were trying to solve. We also held some very special meetings at the White House where we had representatives from the governments in Japan and Korea and from the European Union contribute to what we were actually going to do at the DRC finals. We wanted this to be an international event and actually to begin an entire process where the world on a repeated basis would begin to hold contests of this sort. This really is a wide spectrum of different teams from different parts of the world. They really are trying to make the human condition much better. They're trying to make the world a safer place and lower the incredibly strong emotional burden of what happens when human beings are hurt or killed in disasters. The 18 months between the trials and the finals allowed DARPA and my planning team to reassess our goals and to develop a finals event that would push technology forward and raise the bar for competing teams. We had 2 significant events between trials and finals. The first is that we upgraded Atlas. We made it cordless. We put batteries on it and we made it possible for it to move around without any kind of safety tether without any kind of power tether, and for all the communications to be done wirelessly. The second thing we did is to have a beta test, and we had most of the competing teams come, and we had a mock-up of what we believed the finals would look like. And by the end of March, we could see that there were some strong teams that were ready to compete in Los Angeles.
Ladies and gentlemen, start your robots.
At DARPA, we come to work every single day to change what's possible. And that's our job, to change what's possible so that we can take these huge strides forward. In the next 2 days, 24 teams from around the world are going to change what's possible.
We saw incredible progress in the 3 years since the inception of the project. The robots now were cordless. The robots ran faster, in fact 4 times faster from trials to finals. And most importantly, the robots could deal with communication blackouts that lasted up to 30 seconds long. One of the most surprising things to me about the DARPA Robotics Challenge finals was how evocative the robots were. People weren't afraid of the robots. They actually fell in love with them. And when the robot fell down, there were groans. And yet when the robots did well, the cheers were just incredible. And we realized that there was this incredible emotional bond that was forming between the spectators and the robots that were on the field.
The DARPA Robotics Challenge Finals was a sort of a graduation exercise where an ecosystem of performers came together, showed the challenges that they've overcome, showed the maturity of the technology, and I think what came out of that was tremendous commercial interest.
We set out to make the world more robust to disasters. We've proven that it can be done. Robots still have a long way to go until they are real products, but the race has begun. We have shown the world that technology can actually be developed and it can actually solve big problems. What had begun as a simulation on a computer was now showing tangible results on the ground. Discussion turned from can we do it to future possibilities that we've done it, and now what's next?